Good morning, everyone. Today, we are going to present and discuss the topic that assigned to us. The topic is about the z-test for the mean. In this topic, there are two types of z-test for the mean, the one-sample z-test and the two-sample z-test. But before that, Adelisa will state what z-test all about.
What is z-test? Is a statistical test to determine whether two population means are different when the variance are known and the sample size is large. Z-tests, also known as population variance, z-tests are a statistical way of testing an hypothesis. For this purpose, the null hypothesis and the alternative hypothesis must be set off, and the value of x z-test statistic must be calculated. The decision creation is based on the z-critical value. One sample z-test. One sample z-test is a test used to check if there is a difference between the sample mean and the population mean when the population standard deviation is known. One sample z-test also use of one sample z-test to check and analyze the difference of the sample mean and the population. We can also give decision of the hypothesis to be rejected or accepted. The z-test formula. Z equals the sample mean minus the population mean divided by the population standard deviation and the sample size. Left-tail test. A left-tail test is used when the alternative hypothesis states that the true value of the parameter specified in the null hypothesis is less than the hypothesis claims. Right-tailed test. A right-tailed test, sometimes called an upper test, is where your hypothesis statement contains a greater than symbol. In other words, the inequality points to the right. Two-tailed test is a method in which the critical area of a distribution is two-sided and tests whether sample is greater than or less than a certain range of values. It is used in null hypothesis testing and testing for statistical significance. The example of one sample z-test. A teacher claims that the mean score of students in his class is greater than 82 with a standard deviation of 20. If a sample of 81 students was selected with a mean score of 90, then check if there is echo evidence to support this claim at a 0.05 significance level. Solution. As the sample size is 81 and population standard deviation is known, this is an example of a right-tailed one-sample z-test. Null hypothesis equals 82. Alternative hypothesis is greater than 82. From the z-table, the critical value at a equals 1.645, we will use z-test formula. 90 is a sample mean, 82 the population mean, 81 sample size, 20 the population standard deviation. Our z equals 3.6, as 3.6 greater than 1.645, thus the null hypothesis is rejected, and it is concluded that there is equal evidence to support the teacher's claim.
Two-sample z-test. A two-sample z-test is used to check if there is a difference between the means of two samples. When do we use z-test for two-sample mean? We use z-test for two-sample mean when we compare the means of samples of independent groups taken from a normal population. How do we use z-test for a two-sample mean test? The formula for two-sample mean test is Z is equal to quantity of mean sub 1 minus mean sub 2 minus quantity population sub 1 minus population sub 2 all over the square root of population standard deviation sub 1 all over sample size sub 1 plus population standard deviation sub 2 all over sample size sub 2. Example for the two sample z-test for the mean. The DORSO conducted an admission test to the incoming freshman college in the program of Bachelor of Secondary Education major in Mathematics and Bachelor of Secondary Education major in Science, with 100 students each program randomly selected. The mean scores of the given samples were 85 and 80, and the variance of the test scores were 30 and 20 respectively. Is there a significant differences between the two groups? There are steps in solving a two-sample z-test for the mean. First, we should formulate what is the problem being asked. There, the problem being asked is there a significant difference between the two groups? Next step is we should formulate the hypothesis. For the null hypothesis, there is no significant difference between the two groups. We can denote it as mean sub 1 for the mean of group 1 is equal to mean sub 2 for the mean of group 2, which is there are equal because there is no significant difference between them. For the alternative hypothesis, there is a significant difference between the two groups. We can denote it as mean sub 1 is not equal to mean sub 2. They are not equal because they possess a significant difference. We notice in alternative hypothesis that it is not directional, meaning to say, the test that we are going to use is the total test. The step 3 is the level of significance. The critical value of the z-total test at 0.01 significance level of plus and minus 2.575. Then calculate the statistics. The z-test statistics for two sample means are calculated. First, we identify the given values. The sample mean for both two groups are 85 and 80. They have a variance of 30 and 20, and they both have 100 sample size. Then plug in these values into formula. Now that we get the z computed value, which is 5.938. The step 5 is the decision rule. If the z computed value is greater than or beyond the z tabular value, this confirms the null hypothesis. Let us plot into the graph. The z tabular value of the positive 2.575 that located in the right because it's positive, and on the rightmost part is the z computed value, which is the 5.938. From this itself, the z computed value goes beyond z tabular value, therefore, this confirms the null hypothesis. In conclusion, since the z compound value of 5.938 is greater than the z tabular value of 2.575 at 0.01 level of significance, the alternative hypothesis is confirmed, which means that there is a significant differences between the two groups. That would be all. Thank you. Thank you for your listening and watching. We hope that you have learned something about this discussion or this presentation about the z-test for the mean.